Hello, class. This will be the last official video for this course this semester. This will be the exam for review, which is which is also our final exam. Um, as with the previous exam review videos, I will be going over the full review quiz that's in my math lab. I won't be working every single problem. Some I'll just like making sure we know how to start them because a lot of times on the test, that's where people get stuck. Um, Plus the full review is like 50 questions because it gives you, it's the whole, there's not anything on the full review that's not in the exam. Plus there's a little bit extra because that way I'm not giving you the exact review or the exact test. The other thing that you might want to have handy is that in Blackboard there is the formula sheet, the instructor formula sheet. I remember for this test, you can have that in addition to the one page of notes that you had for the previous tests. Sure, this is showing up. Yeah. So if you go to where is it? Lecture note outlines, instructor unit 4 instructor formula sheet. So I've as I was looking through ahead of time on that full review, there are a lot of questions that have the conversions, but some that don't. And so that's the advantage of working through the quiz is if you see anything on there that you need that's not on the formula sheet, not on the test, that's what your additional page of notes is for. Same with the formulas. Not every single formula in geometry is on the test. Actually, most formulas are probably not going to be on the test, but they are on the formula sheet. And again, if there's anything you need, no, this is a pretty straightforward test, especially compared to test 3 and 2 and 3. For most people, I think this will feel a little bit more like test 1, except it's not as much review of a different variety of topics. So yeah, I don't like to say a test is easy, but I think if you've done all your chapter 9, chapter 10 homework, this should be a relatively straightforward test. All right, well, let's jump into it. This test is about 50-50 between chapter 9 and chapter 10. Um, and as always, these are, this one's 42 questions. So um, if you, let me make sure this is showing up. Yep. So if you don't have time to finish it all at once, then you can always just X out of it and come back into it. All right, but let's just get into it and start playing around and see what we see. Hmm. So all of chapter 9 is about unit conversions. Most of them we set up in class, doing or with the videos using the what I call the railroad track method, using fractions to take the guesswork out of multiplying and dividing. Um, if they're just a one conversion, that's pretty straightforward. Sometimes you'll have a 2, maybe 3-step conversion. You have to do a little bit of figuring out ahead of time, like what the steps are going to be. Like I said, there's nothing in here that you haven't seen the homework if you've been doing your homework. So 48 inches to feet. Yeah, and notice that again, many of those problems they already have the conversions there. On the formula sheet, I do not give you any English to English other than what I give you. Some of the area ones, like square yards to like what I give you, acres to hectares, acres to a mile, that sort of thing. I also give you like 144 square inches in a square foot. So I give you some of the area ones because we don't use those as often in English to English. But for any of these English to English, if you think you're free to get them, you might want to write them down just in case they're not in the problem on the test. Let's see. So let's go ahead and start with the basic one. Just as a warm up. I always kind of, if you haven't figured it out by now, I always kind of like to start my test with a little bit of basic questions just to kind of get you going. 48 inches to feet. So kind of set the pattern is the starting units, put that over 1, the fraction. And now we need a conversion factor. Well, what do we know about inches to feet? We know 12 inches is 1 foot. Now here's where the fractions are your friends because we need to get rid of inches. So to get rid of inches, it's on top. On the next fraction, it's to go on bottom. The 12 inches is 1 foot. So the inches are canceled. Leaving us with foot, which is what we're trying to get. So this is just 48 divided by 20. Now, some of these more basic ones, you may not have to show work. You're like, you might have looked at your number sense and, I didn't need to write this out, which is fine. But just remember on the test, if you have a wrong answer and you have no work, you have no possibility for partial credit. So make sure that, it's on a test, even if you don't think you need it, it doesn't hurt to write, stuff down. And as always, take pictures, email it to me so you can get graded for partial credit or potential partial credit. All right, so going back to, so that's a pretty straightforward problem. Going back to the review quiz. See, like I said, we're not going to do all of these. We'll see which ones we might want to do. So 25,730 feet to a mile. We're given 5,280 feet is 1 mile. Again, if you don't know that, you may want to write it down just in case it's not on the problem on your test. All right, so you're gonna have some English to English, you're gonna have some metric to metric. This particular problem kind of gives you the steps. I'm not big on that. For health sciences, they tend to take more of that approach because all they deal with is the metric system. They don't deal with English to metric very much, other than like pounds to kilograms. So for this class, one thing I talk about over and over is you need to know what the prefix C stands for, just centi. And so there are 100 centimeters in 1 meter. So to set that up, as always, start with, go with what you're starting with over 1. But this is bunch number 3. We have 14 meters. We want to go to centimeters. So start with 14 over 1. Now, centi means 100. So we know that 1 meter, or you should know that 1 meter is 100 centimeters. So what's going to go on bottom? Well, we need to get rid of meters. So meters goes on bottom, and so 1 meter is 100 centimeters. 1 meter cancel, we're left with centimeters. So in this case, we're multiplying by 100. So 14 times 100 is 1,400 centimeters. When you're dealing with things like, inches to feet, you're more used to it, so you don't always have to set this up, like when to multiply and divide. If you don't know that a meter is about the length of a yardstick, and a centimeter, is about the width of your pinky or a finger in general, then you may not know if you're supposed to multiply or divide. That's the nice thing. Again, that's the nice thing about the fractions. If you're setting your fractions up right, cancel out your undesired units. It takes the guesswork out of it before you multiply and divide. The next one, sometimes decimals throw us off. So this is 0.024 millimeters to meters. So again, you need to be able to read your metric stuff. So we're starting with 0.024 millimeters over 1. And now what does milli mean? Milli means 1,000th. So there are 1,000 millimeters in 1 meter. A millimeter is maybe the width of that pen tip, maybe smaller. So well, we need to get rid of millimeter. So millimeter needs to go on the bottom. So 1,000 millimeters is 1 meter. Now we're doing 0.024 divided by 1,000. Again, the nice thing about the metric system and kind of what that chart and the problem is referring to is you're just moving decimal places if you're going from metric to metric. But when in doubt, just go in your calculator. So there are 1, 2, 3, 4 meters. So 0.024 millimeters makes, very small amount of meters. I don't even know we could see. I don't like, I'm trying to think of how thick that is. That's way less than the thickness of a piece of paper at 0.02 millimeters. The math teacher in me says when I see that, I want to convert that to scientific notation. Remember that back from test two? So 2.4, and then we move the decimal 1, 2, 3, 4, 5. Times 10 to the negative fifth because it's a decimal. You know. So if you're going on to a science class, you probably have to answer it that way rather than writing it out. Okay, so that's metric to metric. Um, the kilo, which is 1,000 of the basic unit, a centi, which is 1/100th of the basic unit, and a milli, which is 1/1000th. Those are the most common prefixes. And if you need some of the others, again, that's what your sheet's for, and that's what go through the quiz and see what might show up. All right, so here is one that is centimeters to inches. So this is English to metric. I'm pretty sure every English to metric equivalent is either embedded in the problem or on the instructor formula sheet. Yes. Then again, we have a direct conversion on this one. We know 1 inch is 2.54 centimeters. We're starting with 15 centimeters. So on our conversion fraction, 2.5 centimeters would be in the bottom, 1 inch is on top. So you're basically just doing 15 divided by 2.54. So if you have a direct conversion, then it's a one-step problem. It's about as straightforward as these problems get. Okay, same with miles. We know that 1 mile is 1.6 kilometers. So miles will go on bottom, 1.6 kilometers goes on top. So you're just doing 270 times 1.6. So like I said, this is why, I don't think I need to work through every single problem, especially if they're just, one step. Here's one, feet to meters. So if you look over here, we have feet to centimeters and meters to yards. So we don't have a direct conversion. But means this will be a 2, maybe 3-step conversion. Let's walk through this. And this is where we've seen this in the homework. Sometimes there might be more than one conversion path to get to the answer. Sometimes, whoever coded these problems in MATLAB, if they coded just one path, if you take a different one, then your decimals might be off. But usually I'm pretty close that, MATLAB might count it wrong. But again, if you turn in your work, I'll look at your test. And if it's just basically a rounding issue, because of the conversion factors, you would get full credit. Yeah. So again, that's why it's important to take pictures of your work and show it. Or email them to me. 8 feet to meters. All right. Well, since we're starting with feet in the problem, to me, I would, the 1 foot is 30.48 centimeters. I think that's probably the most common path. If I had to guess, that's like whoever coded this problem would use. We could also, it's 0.9 meters is 1 yard, and then you could convert yards to feet. Like I said, that's going to give you a pretty close answer, but it may not be the exact answer the MATLAB is looking for. And again, that's where if I can tell that you're doing the correct conversion, you would get full credit. All right. So we know 1 foot is 30.48 centimeters. So that gives me from over to feet to metric. But now I need to go from centimeters to meters. And so what do I know about that? Hopefully you know 100 centimeters is 1 meter. If you don't know that, better get that on your page notes. Right, so we're basically doing a 2-step process here. Feet to centimeters, centimeters to meters. We're starting with feet. Put that over 1. We need to get rid of feet. So that 1 foot goes on bottom. 30.48 centimeters goes on top. So now we are done with feet. Now we need to convert centimeters to meters. So centimeters needs to go on bottom. So 100 centimeters is 1 meter. Now the centimeters are done. And I say this all the time. If you have multiple numbers on top and bottom, you multiply everything on top, then get a number, multiply everything on bottom, get a number, and then do the division last. It's the best way to avoid any issues. And when you're in the middle of the problem like this, don't round. I don't care what it says to round the answer to. Don't round in the middle of the problem. Wait till the very end to round. Otherwise, your answer might be a few decimals off. MATLAB can be picky about that, so round at the end, not in the middle. In this case, I'm getting 2.4384 meters. And then always look at MATLAB anytime you have a decimal that's more than like 1 or 2. They're not always consistent on where they round. This particular problem says round to the nearest hundredth. Now it does say round all intermediate values to the nearest hundredth. When it says all intermediate values, they are implying that you could round that when we didn't need to because it wasn't 3 decimal places. I still don't trust it. I don't round until the end. All right, so that 3 is what we're trying to round. 8 says we round up. So that would be 2.44 meters. So 8 feet is approximately 2.44 meters. All right, so that is a good solid 2-step conversion. All right, so we don't have a direct conversion from feet to meters. So you had yeah. And again, just when in doubt with a 2-step conversion, start with the one that has your starting conversion, like your starting units first. Then I think MATLAB is going to be less likely that you go a different path and get a slightly different answer. Like we could have went, let me go back to, so in the problem, it has 0.9 meters is 1 yard. And again, we could have started this problem by saying 3 feet is 1 yard and then converting yards to meters. Let me do that arithmetic right quick. So if I did it that way, I would have got 2.4 meters, but our answer to the other way is 2.44 meters. And so like neither one of those is wrong. It's just these conversion factors are always rounded a little bit. And so that's why, like I said, it's the show your work. When we have any doubt, then I can always go back and check. All right. Well, we want to express 195 miles per hour in feet per second. Okay. And then they give us, they give us the conversions we need. 5,180 feet to miles. That gets us from miles to feet. Then we need to go from hours to seconds. We don't have a direct conversion from hours to seconds unless you happen to know it. So they're converting hours to minutes and minutes to seconds. So we need all 3 of those. So this is going to be a 3-step conversion process. Definitely a good test question. So we need to convert 195. So how do you set this up? So when we have those 2 units, hopefully you remember doing this in the homework. So when you have the 2 units, set the top, so it's miles per hour, so 195 miles per hour means 195 miles in 1 hour. You do the miles on top, the hours on bottom. Okay, that's going to make a big difference in our conversion. So we want to go to feet per second. So to convert miles to feet, 1 mile is 5,280 feet. Okay. So we have the feet, which we want. Now we're going to convert hours to seconds. And so here's where you have to be careful, and the reason why it's important that hours are on the bottom, because in the next fraction, to get rid of hours needs to go on top. And so now 1 hour is 60 minutes. All these other conversions, we've been putting it on the bottom because we started on the top with our unit. Now our unit's starting on the bottom, and so it needs to go on top of the next. And then we're in minutes, but we want seconds. So now 1 minute. Again, 1 minute has to go on top and cancel out the minutes. is 60 seconds. So now if you look at the units, we have feet, we have seconds. So all our conversions are done. So now multiply everything on top, everything on bottom, and then do the division. That's 5,280, not 5,000, not 528, sorry. So this is going to be, I don't know, what, 275, something like that. Guess. So feet per second. So we multiplied the top numbers, multiplied the bottom numbers. Now we do the division. 286, no rounding needed, feet per second. And I went up for the answer. It didn't say anything about rounding. So if it doesn't, especially when you're dealing with big numbers like this, they don't mention about rounding. That means they are expecting a whole number answer. So if you got decimal numbers, especially a lot of decimal numbers, and the instructions does not mention rounding, that means somewhere in your setup, you probably made a mistake, or either put it on your calculator or something. All right, but that is for a non-word problem, this is about as complicated as the conversions get. Because not only do we have to, one, there's 3 conversion fractions that we needed, and 2, we actually had to convert, something starting on the bottom. And so most of them is just starting something on the top. Like I said, that's why that's a good test question. Go back to the test. So these were all like 9.1 questions. Now we're getting into some area and volume stuff. So these were like 9.2. The setup is still the same. We need to convert 16 centimeters squared to inches squared. And do we have a direct conversion? Yes. Now, one thing about these squared units, and again, hopefully you figured this out in homework, but let me review this for the test, is that is 6.5 centimeters squared. That 6.5 does not need to be squared. The only thing that's squared is the units because there's no parentheses around this. So when you set it up, get over 16 centimeters squared. So we know 6.5 centimeters squared, 1 square inch. So that 6.5 is still on bottom. Do not square that because there's a difference between 6.5 square centimeters versus 6.5 centimeters parentheses squared. If there was parentheses around that, you'd have to square the 6.5. Right, but they're telling you the number is 6.5, so don't square it. Just that's your conversion fraction. So whatever 16 divided by 6.5 is. Okay. So get this big old long decimal number. So again, anytime I see that big old long decimal number, I'm expecting MATLAB to tell me something about rounding. And sure enough, when I look at the instructions say round to the nearest hundredth. So we're rounding the 6. So the 1 tells me keep the 6 the same. So 16 square centimeters is approximately 2.46 square inches. And again, MATLAB on the conversion stuff, MATLAB puts the units outside the answer box. I kind of wish they do it like in the geometry and make you put in the units as well. This is a typical area problem. So let's go back to the test, see if there are any more of these we need to do. So the next one is meters squared to yards squared. You have a direct conversion, 0.8 meters squared is 1 yard squared. So that's straightforward. 15 liters to cubic centimeters. Okay, so it may throw you a little bit because it says that's a decimeter cube is 1,000 centimeters cube, but there's also an equals. So they're telling you that 1,000 cubic centimeters is 1 liter. So you have a direct conversion there. So You put 1 liter in the bottom, you're putting 1,000 cubic centimeters on top, so you're basically multiplying by 1,000. All right. The only time metric to metric gets messy is if you're going from like centi to milli, like centimeters to millimeters or centiliters to milliliters. And then you have to kind of have a two-step process because then you need to go like, if you're doing like centiliters to milliliters, probably want to take centiliters to liters and then liters to milliliters. Well, actually, we don't need to do that for volume, but like length or weight, that's something you have to watch out for. Okay. So since I just mentioned it, here's one. 219 milliliters is 1 cubic centimeter or 2 cubic centimeters. Now, normally milli to centi is a bit of work, but this is milliliters to centimeter to cubic centimeters. And so the nice thing about those, you go here on the chart, 1 cubic centimeter is 1 milliliter. So sometimes this throws people because it's a 1-to-1 ratio. So 219 milliliters is 219 cubic centimeters. That's not a mistake. Right? That is like by design in the metric system, that 1 milliliter is equal to a cubic centimeter. If you're converting from that's a cc. As that's probably more commonly called, particularly if you deal with medicine, a cubic centimeter is a cc. But that's the quickest conversion. It's 1-to-1. So I don't even have to do math on that. It's just 219 cubic centimeters. All right. Swimming pool is a volume of 44,218 cubic feet. How many gallons? Do we have a direct conversion? We have cubic feet to gallons. Now this one doesn't have the unit. Okay. Now this one this is what I wish it did. Notice they don't have the units. Well, how many gallons? Don't I know since geometry we talk about volume always being cubed, but remember gallons is a volume measurement, so don't cube it. This is not like it's cubic feet. Feet is a length. We have to cube feet to get a volume. Gallons by design is already volume. So it's going to be gallons. And now how many gallons is it? Well, yeah, basic conversion. So let's do this one right quick. So number 13. We're starting with 44,218 cubic feet. You can write out cubic feet or just put the exponent. So from the chart, cubic feet is about 7.48 gallons. So it's 1 cubic foot. So that's going to go in bottom because we need to cancel out the cubic feet. Is 7.48 gallons. All right, so that's a lot of gallons. 44,218 times 7.48. And they say, so we have 330,750.64. So 330,000 and some change gallons. Now, since this is a big number, my first thought was we usually don't have a decimal. And so looking at the instructions in Math Lab say round to the nearest whole number. All right. This also happens in a lot in like the volume and surface area, like 10.5 chapter or section. So if we're rounding to the nearest whole number, that is the ones place value. 6 says round that up. So 330,756 gallons. 44,000 some odd feet is about 330,000 gallons. All right. So that's a lot of water to fill that pool. Yeah, that's pretty big. That's even if you had a 10-foot pool, wow, so that's, let's see, 44,000. So like if I did 100 feet by 10 feet deep, that's still 44 feet wide. No, that's kind of big for an Olympic size. All right. Sorry, getting sidetracked there. Just the math threw me off. That's a huge number. That's a very large swimming pool. Okay. So I would not want to pay that water bill. So there you go. All right. So again, but it's a one-step conversion because we had a direct conversion from cubic feet to gallons. There was a little bit of rounding, so that's a pretty standard fare problem. Kind of what I was saying about this is if you've done your homework, this should be a straightforward test. Hmm. All right, here's a little bit more of application. So let's work through this one. So the property measures 2 hectares is for sale. Hectares. If you don't know what that is the metric version of an acre. All right. So how large is the property in an acre? So do we have a direct conversion from hectare to acre? Right down there at the bottom, 1 acre is 0.4 hectares, and then we will figure out the price. Okay, so let's go through and set this up. And see, this is where unit analysis really helps us answer the second. Normal conversions for the first one, and then the units will help us on the second. This is 14. So we have 2 hectares. So this is part A. We want to convert this to acres. From the chart, 1 acre is 0.4 hectares. So that goes on bottom. HA is the common abbreviation for that. You'll see that in the chart as well. 1 acre on top. So hectares cancel out. So we're doing 2 divided by 0.4. Once we get all the previous numbers cleared out. So that would be 5 acres. All right, so that's part A, just how big is the property in acres. Now, part B, if the property is selling for $150,000, what is the price per acre? So selling for $150,000. So that's the property as a whole. What is the price per acre? So this is where units tell us exactly. I mean, common sense is probably going to help you out here as well. But when in doubt, price per acre. Look at the units. That per means a division, and then the acre is second means it goes on bottom. So this is price over acre. That's what that price per acre is telling us. So what that means, if you want for sure, is what do we put on top? On top we put the price. So $150,000 over 5 acres. So that's this isn't a conversion problem. This falls under the dimensional analysis idea that that's the official language of the whole chapter. Um, so that would be 3,000. Make sure I had the right numbers here. 1,000, 30,000. Something wasn't looking right there. So dollars per acre. So units can be your friends. So even if you had no clue how to set this up, that will give you the hint in the right direction. Now in MATLAB, let's see how they want us to answer that. The property is 5 acres. The price is 30,000. And then so when you're looking here, it already has the dollars out front. So there's the dollars per acre. That's how they're wanting you to answer that. Okay. And then I get into weight. So this is milligrams per gram. that is now officially section 9.3. Now notice over here, there is no metric chart, conversion chart. So you need to know that milligrams is 1,000, there's 1,000 milligrams in a gram. Again, if you don't know that or you think you might forget, get that wrote on your 1 page of notes. A lot of people in the in-person class, they would like I said, I'd give them a printout of that formula sheet. And so most people would like write on the back of it, some would write on the front. So you can have basically you can have 2 pages of notes if 1 page of your notes is that formula sheet. Okay. So having that formula sheet, basically saves you a lot of writing, which is the idea. Kilograms to grams. So what's the version there? Kilo means 1,000 of the basic unit. So 1,000 kilograms is, or sorry, 1,000 grams is 1 kilogram. So we're going to put 1 kilogram on bottom, 1,000 grams on top. We're multiplying by 1,000. Pounds to kilograms. Do we know a direct conversion? So sometimes sometimes these problems have 1 kilogram is 2.2 pounds. This one has 1 pound is 0.45 kilograms. MATLAB is going to expect you to use the 1 pound as 0.45 kilograms. If you use 2.2 pounds as 1 kilogram, again, that's something I would give you full credit for, but I'm not going to know to look at it unless you take pictures of your work and send it to me. Okay. So because the decimals would be off depending on, if you use the 2.2 pounds as 1 kilogram, like you may be off by a few tenths or maybe a few hundredths, but sometimes MATLAB will accept it, sometimes they won't. But still, that is a 1-step conversion because you have the conversion. Same thing here. Jump around. Okay. So all we did so far, that is typical unit conversions using fractions. Once you get into temperature, notice that the 2 formulas for temperature are in the problem. If it happens to not be in the problem, I have it on the formula sheet. So you don't have to have the formula memorized, you just have to know how to use it. And so we are converting Fahrenheit to Celsius. So which do we use, the C equals or the F equals? Well, if you want C, use C equals. If you want F, use F equals. Right. And when they tell us 36F, they're telling us F is 36. Right. So let's do this problem. What is this? Number 1. So we're trying to find C. So we're saying C is equal to 5/9 parentheses F minus 32 and 36 degrees Fahrenheit. So how do we do that? Well, this is one reason why we did formulas back on test 1, because it's just plugging it in and doing our order of operations. 5/9 times parentheses, 36 minus 32. That's 5/9 times 4. And in the instructions, it says round to the nearest tenth. So even though we have a fraction in our answer or in our formula for temperature, for temperatures, we always want either whole numbers or decimals. So I'd like to put that over 1. So it'd be 20/9. So then I do the division last. So 2.2 forever. Says round to the nearest tenth. So that's the first decimal place. So 2 says keep the 2 the same. So this would be approximately 2.2 degrees Celsius. That's it. If you want C, use C equals. If you want F, use F equals. I mean, the only other way I could make this a little bit harder is if I give you a negative temperature. And then, like, if it was negative 36, then you just got to make sure that negative 36 minus 32, is negative 68. When in doubt, do it on your calculator. Okay, that's what they're there for. Right. So yes, we could have negative answers, if we get cold. That's temperature. I don't think I really need to do a lot of, I feel like I've already done more than enough examples of this. Just, just be aware that they're there. Okay, oh, here's a word problem. So when you get into these word problems, you're getting towards the end of chapter 9 material. All right, if the cost to mail a letter is 48 cents for mail weighing up to 1 ounce and 24 cents for each additional ounce, well, fraction, no, excuse me, find the cost of mailing a letter that weighs 89 grams. All right, so first of all, we're in grams. All the cost stuff is in ounces. We have 89 grams. We need to figure out how many ounces that is. And then what are the costs? So it's 48 cents for 1 ounce and 24 cents per ounce or fraction. So if we go to 2.5 extra ounces, that 0.5 would be, basically a third extra 24 cents. All right, so how do we do this? Okay, so we're trying to figure out the cost of mailing a letter that's 89 grams. Like I said, everything, all our costs is in ounces. So first thing we need to do is how many ounces is 89 grams? So do we know a conversion? Well, it's not in the problem setup. This is English or metric to English. So, that's what I give you the chart for. So 1 ounce is 28.3 grams. So to get rid of grams, we need to be on the bottom. The grams cancel. So 89 divided by 28.3. It's 3.14487 so on ounces. Okay, so do we need to round? Well, remember, if we were stopping with how many ounces, yes, we would round. But here's the key is we need the cost. Okay, so the first ounce is 48 cents. And so I'm just so I'll the cost is per ounce or fraction thereof. So we don't really care about all that. So let's just say we have 3.14 ounces. So the first ounce, so I'm going to take 1 ounce away. That's 48 cents. So we have 2.14 ounces still to buy. So how much do those 2.14 ounces cost? Those 24 ounces, 24 cents per ounce or fraction of an ounce. So there is 1 plus 1 plus, basically, this is how you're going to do it. There's a lot of different ways. So if this is all per ounce, first ounce is 48 cents. Second ounce is 24 cents. Third ounce is 24 cents. And that fraction of an ounce is also 24 cents. So we have 48 once for the first ounce, and then 24 3 times for the 2 full ounces, and then the partial of the third. 48 plus 24 plus 24 plus 24. So that is $1.20. You could kind of set it up, try to set it up as a dimensional analysis problem, but that per 24 cents for the whole fraction or the whole ounce, like fraction of ounce would mess up. We wouldn't get the proper price for that. That's a full 24 cents. Whereas we try to do this like a dimensional analysis, we would only get charged like a fraction of the 24 cents. But you've seen this in the homework, hopefully. So, yeah, it's a good word problem for the test. Great. So, drug dosage calculations, they're in here for all of you that are allied health. This is, this is a problem I took directly from a nursing student at Subway with their homework. So this is definitely a good application of dimensional analysis. So the prescribed dosage of a drug is 8 milligrams per kilogram daily, meaning that 8 milligrams of the drug should be administered daily for each kilogram of a patient's weight. How many 100 milligram tablets should be given each day to a patient weighing 167 pounds? Use the fact that 1 pound is 0.45 kilograms. All right, so on a problem like this, that's a word problem for a conversion, you need two things you really need to know. One, where are you starting? And two, where are you trying to get to? Then we'll worry about the conversions to get there. All right, so if you're doing these drug dosage calculations on patient's weight, that patient's weight is where you're starting. So in this case, it's 167 pounds, and that is our starting value. So at least we have that. Now, what are we trying to get to? So how many 100 milligram tablets? So the question is, how many tablets? That is what we want. So we know where we're starting, 167 pounds. We know where we're trying to get to. Now, how do we connect the two? Well, they give us 1 pound is 0.45 kilograms. So we're starting with pounds, and we'll be able to convert pounds to kilograms. Any of these word problems like this, when you have something that has 2 units like this set up as a fraction, at least 95% of the time, that's one of our conversions. So we're going to be able to convert kilograms to milligrams of medicine. Now, one of the things you have to be careful of in problems like this and in chemistry, we're not trying to convert like kilograms of weight, like a person's weight, to milligrams of a person's weight. This is kilograms of a patient's weight to milligrams of medicine. So even though the grams is in both of them, we're not trying to convert those directly. Okay, that's what that conversion is for. That can be that's probably the most confusing part for students new to these type of problems. In the same way in chemistry, right? But we're talking about kilograms of weight, milligrams of medicine, so those are completely different. So once we get to milligrams of medicine, are we done? No, because we need tablets. And then that's where it says 100 milligram tablet. So one tablet weighs 100 milligrams. So that's the challenge of these word problems, is figuring out what we know, and what's what. So let's get this wrote up and see how it goes. Okay, so we know we're starting with a 167-pound patient. They tell us to use 1 pound is 0.45 kilograms. They also tell us that 8 milligrams of medicine is for 1 kilogram of patient weight, and that 1 tablet is 100 milligrams. All right. So we're starting with pounds. We're going pounds to kilograms. Then kilograms takes us to milligrams of medicine. And then milligrams of medicine takes us to tablets. Okay, so this is going to be a 3-step process. So we're talking about patient's weight. Starts at 167 pounds. We know where it is. 1 pound, shows on the bottom, is 0.45 kilograms. Now we need to convert from kilograms of weight to medicine. So that's when we use this. Kilograms is on top. Now here's where you have to be careful. You could potentially have to flip this, but kilograms is on top here, kilograms is on bottom here. So we don't have to flip it. We know that 8 milligrams of medicine goes to 1 kilogram of patient weight. So I'm not saying that those 8 milligrams of medicine weighs a kilogram. It's just that we need 8 milligrams for every kilogram of patient weight. And then what are we going to do? We need tablets. So we know that one tablet weighs 100 milligrams on top. So now it goes on bottom, and one tablet goes on top. Like, this is really what all this dimension, like all of chapter 9, all the dimensional analysis stuff is leading up to problems like this. Because, at least half of you are going on to chemistry or your allied health or both, or you're going on to another science class. This is really kind of the sort of level that you'll need when you get to chemistry or your nursing math classes. Or, like I said, any science class. This is a very typical science class question. All right, so now we've got tabs, which is what we're looking for. So multiply everything on top. 167 times 0.45 times 8. That's 601.2. On the bottom, 1 times 1 times 1 times 100. We're dividing that by 100, so it'll be 6.012. Now, how do we round? Well, before we look at math lab, we're dealing with tablets, right? Can you give somebody a fraction of a tablet? That wouldn't make sense. And in instructions, it says round to the nearest whole number. So 0 says keep the 6 the same, so that would be 6 tablets. All right. So I kind of like this one a little bit better than the postage one. They're both good problems, but this one is a little bit more like accounting, like shopping question. I kind of like the more direct conversion. Like I said, like this fraction of an ounce kind of makes it a little bit weird. This one, this is a great question from a math instructor's viewpoint. All right. So that is the chapter 9 questions. Right? That's all the conversion stuff. And there's more examples here in the full review if you want them when you got the skill check quizzes. But now let's get in there and see what you have to do for chapter 10. All right, so find the unknown side of the triangle. So how do you do that? Well, this is where, and I didn't give this to you on your formula sheet. You have to know this is a right triangle. So this is used the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. Do you know how to use it? We get all the numbers wrote down and then we'll go from there. All right. So we're trying to find the missing side. We know a squared plus b squared equals c squared. So not only do you have to know that it's a Pythagorean theorem problem in general, you have to know what's the a, what's the b, what's the c. And hopefully, again, if you've done the homework, you're familiar with the fact that the a and the b make the 90 degrees, and then the c is the long side opposite the 90. So that is the c. And it does not matter which one of these two is A and B, that they are interchangeable, but A and B are not interchangeable with C at all. Okay. All right. So to use the Pythagorean theorem, one, you have to know when to use it. And then two, what's the A, what's the B, what's the C? One of those three we're looking for. So now you just plug our values in. So 32 squared plus 24 squared equals C squared. And then again, this is why we did all that formula stuff. Just square those. That is 1024 plus 24 squared is 576. Add those together. So you get 1600 equals c squared. And then sort of like the new thing here is how do you solve for c? Well, we don't want c squared, we want c. Well, once you get it down to a single number equals your square term, just take the square root of both sides. Because the square are opposite operations, they cancel each other out, just like multiplying by 7 and dividing by 7. But if you're squaring something, you take the square root to undo it. And then again, you should have done this in your homework, but make sure that you go in the calculator, do your square roots. All right, so if it's a whole number, great. If it's not a whole number, so let's say we're going to do square root of 1500. Now notice this calculator already gives me a decimal. Some of you, particularly like the ones we're using in class, they're all set up in math mode. Let's see here. Okay, so this one's still in math print. So the reason it gave us a decimal it automatically on that is that 1500 is a big number, but let's say I did square root of 50. So if you have a smaller number, it's going to give you, that's what we call the exact answer. MATLAB does not want the exact answer. They want the decimal answer. So you have to know if your calculator gives you that, how to get the decimal. This calculator above the enter has that double arrow. It converts fractions to decimals and it converts square roots to decimals. So you hit that. So 7.07. Some calculators have an S to D button, but whatever your calculator is, make sure that you know on something like square root of 50, that if you're getting the square root answer, you need to be able to get the decimal answer to get full credit. Because MATLAB will, I mean, if it was square root of 50, 5 square root of 2 would be not incorrect. But like I said, MATLAB wants decimals to get full credit. If you gave me 5 square root of 2, and the answer is supposed to be 7.07, I'd probably take off 1 point because this is something that you should have figured out in the homework that MATLAB wants the decimal answers, and instructions that talk about rounding. And so I would take off 1 point because you didn't fully follow instructions. All right, so that is Pythagorean theorem if you don't know C. I'm guessing the next one is they give us C. So let me just break that one up without going back to the test. Now notice they didn't put the little 90-degree angle right here, which they technically should have. But in the problem, it says use the Pythagorean theorem to find the missing length of the right triangle. So in the words, they tell you to that it is a right triangle. We got a squared plus b squared equals c squared. So we don't know a. Okay, so which is b, which is c? Well, a and b make the 90 degrees, and then c is that side opposite the 90. That's why I say that. And I think they were kind of deficient not putting that right angle there, just to make it clear. Okay, so A is A. We don't know A. If you want to put X there, that would be fine. Then B is 12. So we got 12 squared equals C, which is 18 squared. So now you just do the arithmetic. 12 squared is 144. 18 squared is 324. So how do you solve for A? Well, don't take the square root yet because we can't take the square root unless the square term is by itself. The first thing we need to do, subtract that 144 from both sides. Okay, squared is, what is that? 180. All right. So this is what happens sometimes when I try to do arithmetic when I don't have lunch yet. There, so 324 minus 144. Yeah, 180. Okay. All right, so now we have the square term by itself. So now you take the square root of both sides. Okay, so square root, square, cancel each other out. That's why we're doing that. Okay, so square root of 80. So again, this is where it gives us the exact answer in simplified radicals. In the problem itself, it says round to one decimal place as needed. So that tells us they're wanting the decimal. Remember to get the decimal. However you do it for your calculator to one decimal place, this would be 13.4. What are the units? We're dealing with centimeters, so that does not change. All right, so that's how you're what you're gonna do with Pythagorean theorem is either you have to find C or you have to find A or B. Now, this problem I'm not gonna work all the way through. I know I definitely did that in the homework video for this section, so I'm just gonna talk about it right quick. So why is this here? Well, to find that length, we don't know that that's 90 degrees. Okay, we only know that that's 90 degrees, which means this is 90 degrees. So what you can do is if you just look at the left side, you have a right triangle. You have the hypotenuse, you have one of the legs, you don't know the bottom leg. And on the right side, you've got the hypotenuse, you've got the C, you've got the height, the 24, you don't know the bottom. So this is two Pythagorean theorem problems where we don't know the leg on this side, so like we don't know the A, and over here we don't know the A either. I'd probably call that X and that Y, but just two Pythagorean problems. So this is like two number 25s that we just did. Do that twice and then add those two together. All right, so that's as complicated as Pythagorean theorem is going to get. All right, and then how do you find the perimeter of any object? You add up all the outside edges. So what do you have to know to be successful here? It's a rectangle, so opposite sides are equal. So top is 10, the right is 7. Add them all up. And then what are the units? Well, perimeter is length, so it's one dimension. So that's just yards. Remember, area is squared, volume is cubed. Okay. So just add up all four edges, not many yards. All right, what do we do here? Well, they tell us a square, even if they had it drawn a little off the scale, like a rectangle, if we only give you one measure, you have to assume it's a square. So it's 120 on all four sides. Perimeter, just add up 120 4 times, and it's that many inches. All right, so this is about as complicated as perimeter questions get. Let me draw this picture and then we'll get in detail. So that is 8 feet. That is 8 feet. This is 11 feet. 16 feet. So how do we get the perimeter of this object? Oh, and there's right angles all over the place that I didn't draw. So what all those right angles tell you is that these are all rectangles. Okay. All right, so to get the perimeter, we need all the outside edges. Got the top, that side, that, but we don't have the bottom, and we don't have the left side. All right, so when you have missing pieces, you have to figure that out first. That is 10 over here, not 11. All right, and one thing you might do is like try to focus on just horizontal or just vertical. So if I'm trying to find the bottom, I don't know the bottom. What are the horizontals? Is the 8 foot and the 11 feet. So how do we use that to get the bottom? Well, when you're missing sides on these type of problems, you have two choices. One, if you don't know the total, you have to have all the pieces. So you just add those pieces together to get the total. The bottom is 19 feet. The other choice is if we knew the total, let's say that we knew this was 19 feet, but we didn't know the 11. How would we get that? Well, if you know the total and one of the other pieces, just subtract the pieces from the total. So 19 minus 8 would give you 11. So if you don't know the total, you're adding up both the smaller pieces, If you do know the total and not one of the pieces, you do all the other little pieces in that direction and subtract it from the total. But again, right now we're dealing horizontal, so only deal with horizontal measures. Okay, so what about the vertical measure on the left? Well, again, that's a total. This the big length. We know that's 8. We know that's 10. So we'll add those together. All right. So now we know the bottom is 19. We know the left is 18. And so how do you find the perimeter? Just add them all up. Now that you know all the sides. I like to pick a point and then go clockwise. That's just how I do it to make sure I get all the measures. So 8 plus 8 plus 11 plus 10 plus 19 plus 18. Add those all up. We're dealing with feet, so our answer is still in feet because it's just perimeter. It'll be 74. And again, a problem like this probably wouldn't hurt to like re-add your math just to make sure, or I've got 1, 2, 3, 4, 5, 6 sides. I've got 1, 2, 3, 4, 5, 6 numbers. All right, so that's how I can make perimeter messy for the test, is give you an object that has missing sides. Otherwise, perimeter is very basic. All right, so then we get into area. Now again, if you look at that formula sheet, I gave you circles. I gave you circumference of a circle, area of a circle. Circumference is length, so it's not squared. Area is squared. There's your area, rectangle, square, parallelogram is length times width. Triangle is 1/2 base times height. The one thing I didn't get on here that I probably should have is for trapezoid. That's the quadrilateral that like two sides are parallel, the other two are not. This would be 1/2 height times base 1 plus base 2, where the base 1 and base 2 are those parallel sides. So it doesn't really matter like the top and the bottom, doesn't matter which one's base 1 and base 2. Basically, you're just trying to find the average, 1/2 times adding them up. That's the average of those two. We're basically trying to make a rectangle with the average length of the top and the bottom, or the whichever sides are parallel. So that is that 1/2 B1 plus B2. That is basically length times height. All right, and then I give you the surface area and the volume formulas. So those are all good. Okay, but again, that's if you don't have this printed out, because you can't print out stuff at home, then you need to make sure that you have those formulas typed up, because most of the problems are not going to have those in there. All right, so let's go back to quiz. All right, use the formulas developed in the section to find the area of the figure. So that's a triangle. So area of a triangle is 1/2 base times height. Okay. When we're talking about triangles and parallelograms, you really have to be careful, like which measure you use. They have to be at 90 degrees to each other. So the only two measures we can use for this triangle is the 4.4 and the 8.1. So even that 4.4 is not part of the triangle itself, like the 5 yard, it's not one of the outside edges. That is the perpendicular height to that base. So you have to use the 4.4 and the 8.1 if you're looking for area. If you were to use a perimeter, we wouldn't care about the 4.4, we would just add those together. Okay, but that's one of the weirder triangles, is that the height is sort of outside of the triangle, but it's still the height. But just 1/2 times 4.4 times 8.1. Oh, here's that trapezoid. So let's go ahead and do this one. So I just gave you that formula. We'll get a tron, and then we will get everything label. And I apologize in advance, my parallel sides are not parallel, but I'm just going to say it's not to scale. I'll take care of it. All right. So how do we get the area of a trapezoid? All right. So area of a trapezoid is 1/2 height times B1 plus B2. And so the B1 and the B2 are the parallel sides. Okay. Those are supposed to be the parallel sides. So those are B1 and B2. Doesn't really matter which one's which. Okay. The height is that perpendicular height. Just like that previous triangle, you need perpendicular height. We don't care about the slanted sides because we're not looking for perimeter. For the area of a parallelogram, or sorry, area of a trapezoid or parallelogram, both, you need that perpendicular height. If this is a parallelogram, this side would look like that, but it's still, we would still need, that. But then the two sides would be the same, so they'd both be 20. Trying to confuse the problem. All right, so 1/2 height is the 7 meters. Base 1 is 15, base 2 is 21. So again, just following order of operations. 36. I would put both of those over 1. And then let's just do the math. 26. Now, what are the units? The original units are meters, but now we're dealing with areas. Area is always squared. So it is square 126 square meters. Put in your number and then choose your area. Okay, so how do you find the area of this shape? Okay, well, there's two ways you can do it. You can either split this up into two rectangles, or for some people, they think of that, they look at that as like a big rectangle missing a smaller rectangle. I'm going to split it up into two rectangles because I think it's a little bit more common. But some people, they would look at that and then like get the area of the outside and then get the area of the inside, sort of the missing piece, and subtract it. Just if that works for you, then by all means do it that way. But again, this is where showing your work is important, because if you make a mistake, I can look at it and kind of see what kind of mistake you made. But if you just give me an answer that's wrong with no work, and I have no clue where that's coming from, then don't expect partial credit. Okay. So, how can we do this? Okay. You can either split this up into, it doesn't really matter. You can do it this way. We'll call this number 1, and then this number 2. Or you could have the whole vertical is number 1, and then this little piece is number 2. It doesn't really matter. But what matters is make sure that you're labeling all the sides correctly. And then once we find the area of each one, we're going to add them together. All right, so what do we know? Usually one object is going to be quicker than the other. Like this number 2, we know that's 4 on top. We know that is 12 on the side, and like the other side is 12. That's length times width. That one's the straightforward one in this case. What do we have? We are in meters, so meters squared. It's 48 meters squared for that one. So usually one of your objects, you don't have any figuring to do, like on the links, it's gonna be straightforward. The second, what the other one is going to have some work. All right, so what do we know about this bottom rectangle? Well, we know that is 3 meters. And then what do we know about the length? Well, we know like this part of it is 10, but what about this part of it? Well, by properties of rectangles, that would also be 4 meters. So together, that would be 14. So typically, when you have a problem like this, you're going to have to do a little bit of figuring, at least on one of the sides. But once you do that, it's length times width, because it's just a rectangle. So 3 times 14 is 42 meters squared. And then you just add those together. So what is that? 90 square meters. All right. So that is the more, just like with the perimeter, when you have the missing sides, this is a more advanced perimeter problem. This is the more advanced area problem because you can't just look at it and have follow one form. You kind of have to do a little bit of work to get the pieces. All right. What else do we have? Same thing here. It's just this one, like you have a triangle on top. So triangle is 1/2 base times height. So there you got to figure out the height. How do you figure out the height of that triangle? Well, the total height is 25. The height of the rectangle is 15. So 25 minus 15 is 10. So that's the height of the triangle. And then from there, that's rectangle and triangle, pretty straightforward. All right. So circles. Talked about this in the video multiple times. I know it's where you have to be careful is this in terms of pi. When it says in terms of pi, type in the answer in terms of pi. That means do not plug in 3.14. Leave pi as pi. Okay. So notice there's two parts. They're going to find the circumference in terms of pi and then find the circumference rounded to the nearest tenth. When it says round to the nearest tenth, that's when you plug in pi's 3.14. I wish MATLAB wouldn't do this top part because that's not normally how we think of it. Normally what we do is once we have pi, we just automatically plug in 3.14. But this is the way the problem is. And again, if you've done the homework, you should have already, in the quizzes, you should have already dealt with this multiple times. Okay. So the other thing is for circles, do you have the radius or do you have the diameter? Okay. This is halfway across, so that's the radius, so we're fine. If that was all the way across with diameter, don't forget you need the radius, so you divide the diameter by 2. And then the other thing is, what are the formulas that you're using? Let me go over here and do this one really quick. Centimeters. So again, that's halfway across, that's the radius. So for circumference, well, on the formula sheet, it is labeled C, but the way I remember this is area is always squared, so I want the pi r squared for area. Circumference is the 2 pi r. We know r is 9. So in terms of pi, leave pi as pi. All right, so you're just doing 2 times pi times 9, so that would be 18 pi centimeters. So this is in terms of pi. That's what they're wanting for the first one. Do not plug in anything for pi, leave pi as pi. So that's part one. Part two, when they say round to the nearest tenth, they're telling you plug in 3.14 for pi. So now just do 18 times 3.14. And no reason, don't do the whole formula again because you got it right there. And so 3.14 times 18 is 56.52. They say round to the nearest tenth. Again, make sure to read those rounding instructions. The nearest tenth, this would be 56.5. And then we're still in centimeters because circumference is length. So for circumference, you would give both those answers. That's the in terms of pi one, that's the one rounded nearest tenth. Area, you would do the exact same thing, except now it's pi r squared. Okay. So in terms of pi, do not plug in pi for pi. Leave pi as pi. Radius is 9 squared. Do your exponents first. So that's 81. Now, when you put in the answer, that would be acceptable, but think of that like the pi is an x. We wouldn't say x 81, we'd say 81x. So I would write that as 81 pi. And then what are the units? We're doing area, so that is squared. So centimeters squared. So that's the answer, the area in terms of pi. And then part two, plug in pi as 3.14. And then, like we normally would. 254 point, it's 34, so that would round to 0.3. Right. So if you have a circle or a sphere and by itself, expect this in terms of pi. One where you have like pi as pi, and then part two where you have to plug in 3.14. Now, if it's a compound figure, like when we had some of those with like hemispheres or semicircles, then you're not gonna, for those, they don't want it in terms of pi. They just want because you're gonna be like doing two, like if this was like a semicircle on top of a rectangle, then we wouldn't worry about the in terms of pi up here. We'd just be plugging 3.14. But if you have just a circle by itself or just like a sphere by itself, expect those in terms of pi issues. All right, so that's circles. Here they give us the diameter because that's all the way across. So the only difference here, before you get started, 48 divided by 2 is 24. So the diameter is 48, but the radius is 24. So 24 is what you'd be plugging in here. So that's this. Once you know that, it's the same as what we just did. All right. Okay, so now we get into volume. So how do you find the volume of a box? It's just length times width times height. Doesn't matter if it's a cube or if it's a rectangular box. The only difference with the cube is all three of them will be the same, but it's still length times width times height. And then we're dealing with volume. So volume is three-dimensional, so it'd be cubic inches. Makes it, this is a cube, yes. So it's a special box, but it's still length times width times height. All right, so find the volume of the figure, which means one, you have to be able to identify the figure as being a pyramid. So what is the formula for the volume of a pyramid? Yeah, that's why I give you a formula sheet. And again, if you don't have it printed out, then you'll need to reproduce it. So pyramid, 1/3 capital B times H. The big thing on pyramid, that capital B is the base area. Like what is the area of the base? Right. So it's either going to be a square or a rectangle, or if it's a circle, then technically it's a cone. But remember, a cone is a pyramid. It's just a pyramid with a circular shape, circular base. Okay, so both of those have the same forms. All right, so what is this 1/3 base area times height? You get this drawn. Then we'll. Oh, I didn't. Thought I was sharing the Math Lab version. I'm sharing my work. Okay, so we'll do it here, and then I'll show you the pictures of them already in here. All right, so volume for pyramid is 1/3 capital B base area times height. So what do we mean by base area? Base area is the way we're going to orient it is always going to be the bottom. Well, what is the bottom shape of that pyramid? It's a rectangle. So the base area is going to be length times width, and then the height So now we can just do 1/3. Length times width is 6 times 8. They tell us the heights. They could draw that like a perpendicular and drop it down, but they just tell us that the height is 13. So the number one mistake on volumes of pyramids is students treat that capital B as a little b and just do 6 or 8, not both. And that's a base area, so we need to do length times width, unless it's a circle, and then it would be pi r squared. Times 8 times 13. That's 624/3. So this is a whole number 208. And again, in this section, they're big on like rounding to nearest whole number. It says as needed, but it is a whole number, so we don't have to round it. So it's 208, and then what are the units? We're dealing with feet. Volume is three-dimensional, so it's feet cubed. All right, so that's what you have to watch out for with pyramids. Is make sure that bottom area is an area calculation. That's what I meant to share before. All right, so there's a nice picture. Okay. All right. So here's our cylinder. So volume of a cylinder. Well, if you look on the formula sheet, if you have it, volume of a cylinder is pi r squared h. And where that comes from is a cylinder is basically just a circle that is extended in three dimensions. So it's that area of the top or the bottom times the height. So it's still length times width times height, kind of, except instead of having a rectangle, we have a circle. So that's where the pi r squared comes from. Once you know that, notice they do this whole in terms of pi thing again. So you would just the radius, they give us the radius, not the diameter. So this is, once you have the right formula, it's just plug it in, pi times r squared times h. Pretty straightforward. All right, let's do this one. And again, just like with perimeter and area, this is how we make the volume problems a little bit harder, is give you multiple shapes. So what you have to know is that this is a cylinder. And when you see my cylinder, I apologize that the cone part of the cylinder is really ugly. 2 inches tall. Yes, 8 inches. And this is definitely, notice this is definitely not to scale, because the 10 inches is like what, 3 times higher, the longer than the 18-inch width. Okay, so and notice they are doing in terms of pi. The reason they're doing this in terms of pi is both of these have circles involved, so we'll deal with that. All right, so let's walk through this. This is the top end volume problem. All right, so first thing is you have to recognize that that cone is a pyramid in terms of volume. So what is the formula for the volume of a pyramid? For a cone, it's that 1/3 base area times height, 1/3 capital B times H. And then we have a cylinder that this is sitting on. And so what is the volume of a cylinder? Again, that's that volume is volume equals pi r squared h. So just like with the advanced area problems, we're going to split this up into cone and cylinder, get the volumes, and then add them together. So what do we know about the cone? All right, so we need, for a cone, we need the base area. We need the area of that circle. and then we need the height. So what is what do we know about the base area? Well, we know the diameter of the cylinder at the bottom is 18 inches, so that means this is also 18 inches. And so the diameter is 18. Divide that by 2 to get 9 inches for the radius. Now for the height, what do we know about the height of this cone? Well, we know the overall height is 10. We know the height of the cylinder is 8. So 10 minus 8 is 2 inches. That's the height. Okay, so volume of a cone, since it's a pyramid, is 1/3 capital B, or base area, times height. The base area, we're dealing with a circle. So the area of a circle is pi r squared. And then we want the height. Now it does say in terms of pi. So remember, leave pi as pi. Radius is 9. Height is 2. All right, so how do we do this? We're gonna do exponents first. So 9 squared. And then times 2. So that would be 162 pi 3. Like I said, on this one, if you went straight, if you just plugged in the number for pi, I don't know, I might take off 1 point if you like didn't stop here. Like I said, that this seems a little silly for these objects. So 54 pi. Now plug in pi. (9.56) yeah, inches cubed. So we need both of those. Okay, so that is the cone. Now we need the cylinder. The volume is pi r squared h. Now here's where we have to be careful, because while the radius is the same, the height is a different height, because the height of the cylinder is 8 inches. Now we previously figured out the radius is half of 18, so radius is 9. So on the cone, the height was 2. On the cylinder, that had a height of 2. With the cylinder, we were given the height of 8. So radius is 9 squared now times h, so 8. So that would be 648 pi. And then we need to plug in pi is 3.14. The second half of the answer. And again, don't round in the middle of the problem. Wait until the final answer. All right. So 648 pi cubic inches, or 2034.72 cubic inches. Okay, so for the total, so in terms of pi, we're doing, where was it, 54 pi plus 648 pi. Treat pi just like an x here. So that, like this was 54x plus 648x. The pi is just going to come along for the ride. So it'd be 702 pi cubic inches. Or for part 2, now we add when plugged in pi 3.14, we got 169.56 and 2034.72. So add those together. Or you can just do this times pi, either way. No, said round to the nearest whole number. I need to slow up a bit here. Read the instructions. So that is the nearest whole number of 2 sets cubed 4 the same, so 2204 cubic inches. So if I was doing this problem, what is this, 5? This would be 5 or 6 points because there's a lot of steps. This might be 1 point. This would probably be 5 points. Well, actually, the units being inches cubed both time be 1 point. And, but like I said, for this problem, this compound problem, I'm definitely more interested in that. If it was just a cylinder or just a sphere or just a circle, then, be a little bit more careful with it in terms of out of it. We have to do a taker test via MATLAB, so that's what it's looking for. But again, it's the way we found this volume is we had to find the volume of the individual shapes. And we had to do a little bit of work to get the height of the cone. We were given the diameter, so we had to know divide it by 2 to get the radius. But once we did that, you got to know that a cone is a pyramid. So that's, like I said, this is sort of the high end. But again, I'm giving the formulas. You just have to know how to use them. All right. Almost done. There's 2 problems left. Actual test is like 25 questions or so. Okay, here's where you have to be careful because the test ends in surface area. Okay. So how do you find the surface area? Make sure you're reading the questions, right? I have a lot of people miss this problem because they just give me the volume. So, make sure you're reading the question. So how do you find the surface area of a box? Well, a box has 6 sides. It has the top and the bottom, the left and the right, and then the front and the back. Okay, so how do you find the volume, the surface area of that? Well, if you look on your formula sheet, surface area of a rectangular box, which is 2 times length times width, plus 2 times length times height, plus 2 times height times width. So I give you the formula. Where does that come from? Well, like on there, if this is length and this is width, well, that 4 times 9, that's the bottom and the top. And we need 2 of them because the top and the bottom. That's where the 2 comes from. 2 times length times height. Well, if this is the length, that's the height. Well, that is like the left side and the right side is the same, so we got to multiply it by 2. And then the height and the width. So that would be the 8 and the 9, so that would be the front and the back. And then there's 2 of them, so we're going to multiply it by 2. And again, it doesn't really matter which one's length and width and height because you could rotate this box, but you need the length and the width, you need 2 of those. You need the length and the height, you need 2 of those. And you need the width and the height, you need 2 of those. And that's exactly what the formula is. So what I would do on this, I would say L is equal to 4, W is equal to 9, H is equal to 8, and just plug it into your surface area formula. This is a cube, so you could say 6. There is an official formula for 6 times s squared. What does that mean? S is the side of the cube. And so like if you want the front, that would be 3 times 3. That's where the s squared is coming from. The reason it's 6 times that is all 6 sides are the same. But really, when in doubt with boxes, just treat this like a rectangular box. So you could always do the 2L plus 2LH, 2LW plus 2LH with 2HW that we use in number 41. Right. So the only difference between 41 and 42 is the length, width, and height happen to all be the same. Okay, but we're not going to get too messy with surface area. There are other formulas out there, but I think that since this is this is what's in the practice quiz, that's what's on the test. All right. Well, hopefully that helped. Like I said, I still think that if you've done your homework and you've done your quizzes, especially if you took your quizzes each like at least once as an actual test and missed, see what you missed, that'll give you something to study on. I do think this is the most straightforward of the tests this semester. I did try to kind of end the semester on a little bit of a lighter workload, I guess, because I know a lot of your classes because I've been a student, they tend to really kind of load up on the last couple of weeks. I was trying to not do that with this class, so hopefully that helps. Um, but this is it. And as always, if you have any questions, always email me. Good night.